So everything I just said, if you did this right, but you didn't get that answer, it's just because your calculator is in the wrong mode, and I don't care right now because we're not doing trigonometry till way up here. Okay? I just put trigonometry. Hello, Manuel. How are you?
I was in the office with your house.
Are you in trouble?
No, but they...
It's okay, man. I'm just kidding.
They screwed some papers.
Oh, okay. Have a seat. Well, anywhere you want. Somebody took your seat, I know. That somebody may or may not have been Paneet. Because Paneet remembered that on Monday I said everybody could sit where they wanted because I would hopefully know everybody's names. We're going to see later, AJ. Later. I'm going to take attendance and you might catch me doing this and looking at you. And that means I forgot your name. But I didn't forget Willie's name. I looked at somebody whose name I remembered. So when I looked at him like I was going to forget, I wouldn't have forgotten. See what I did there? I know, right? Anyways, we're not doing trig till way up there, so it doesn't really matter. Yeah? Everybody cool? Now, how many of you have had a teacher in math class especially, because it's always in math class, you do all the work right, you get the answer wrong, and the teacher takes out his or her or their red pen and gives it a big X and says everything's wrong? I know, Maxim. More kids could have put up their hand because everybody's had a teacher that does that. I'm not that guy. But let's say, what are you doing? Solve your problem, dude.
I don't care too much about a chair, so...
Yeah, but you got to write.
I completely forgot. I took all my papers out of my bag over the weekend, and I was in such a rush.
Okay, whatever. All right. Okay. I don't know where the chair has gone. Is there an extra one over there somewhere? There's two over there, Navraj. There's one behind the desk. There's one behind that desk, but there's supposed to be 30. Somebody stole a chair from me on Friday. You guys were here. Who stole the chair? Some grown-up come in and steal a chair? I know that. But see, Alex, if somebody came in first block and stole a chair, then you would be the class I would ask. So you would all say, no grown-up came in and stole a chair. Then I will check with my next block. Okay? Any grown-ups come in and steal a chair? People are jealous of my chairs in this room because I have all the blue ones that are good chairs. There are two over there? Oh, there it is. Nobody stole a chair. I shouldn't have automatically thought that somebody stole a chair. No. But that being said, I've lived with humans for 47 years, and if something's missing, somebody probably stole it, because humans are horrible, horrible, horrible creatures. I would love this planet so much if it wasn't for the people. Not any of you. You don't count. You're all cool. I mean all the rest of the people. You know what I mean? Okay. Anyways, I'm not that guy. But if you don't show me work and you give me a wrong answer and the question's out of 4, what mark am I giving you? 0, because you showed me no work and you have the wrong answer. Picking up what I'm putting down? You remember back in grade 8 when you asked your teacher 1,000 times, do you have to show work? And your teacher said yes every time. And then the next question you would say, do we have to show work? And the teacher would say yes every time. And the next question you would say, do we have to show work? And the teacher would say yes every time. And then you would do it to your grade 9 teacher and your grade 10 teacher. Don't do it to your grade 11 teacher. Okay? All right. I erase that giant red X because red X's hurt feelings. This is true. They tell us in teacher school not to use red anymore to mark stuff because it's an aggressive color. I don't know. Next question, more trig. Everybody's favorite. You could have done the triangle this way and put 74 right there. And then, of course, you would have had to put 6 right there. And then the hypotenuse was right there where you would put an X. But you also could have done it this way. Put the 90 degree right there, put the 74 right there, which would have made that 6. And would have made that the hypotenuse still. Does it matter which way you did it? Of course not. Because if you do it the blue way, you have to do the cosine of 74 equals 6 over x. And then, of course, because the x is in the denominator spot, you would cross multiply and end up with 6 divided by cos 74. Or over here, you would have done the exact same thing, just the triangle would look different. Yes? And it still would have been the same answer, 6 divided by cos 74, which I don't know, again, off the top of my head, but my calculator knows it, and it is 21.8. Now, or you could have gone 21.77. Now, this is a time that I'm going to explain this to all of you. 1 decimal is just fine unless I specify otherwise. Everybody cool? 1 decimal is perfect. Don't worry about it. And, of course, the last trig one. Solve ABC. That means you tell me all the parts. I needed this, and I needed that other angle. Well, that other angle is, of course, 60 degrees equals Z, because the angles of a triangle add to 180. And then you had lots of options. It didn't really matter how you did it. I would have probably done cosine of 30 equals 20 over y. So y equals 20 divided by cosine 30. And then I would have done sine, not sine, idiot head. I would have done tangent of 30 equals x over 20. So 20 times tangent 30 would have gotten me x. And the two answers, of course, are, anybody want to give me either of those answers? Because we've been doing this a while now, and you could jump in and show everybody how smart you are. Anybody want to tell me what y is? Anybody? Say it loud and proud, Lily. Well, I can't read it upside down. Look at how old I am.
Well, which one do you want?
Did you get the first two right, so you know what you're doing? Tell me what y is. This one, the hypotenuse.
Where did I put it? He wrote it weird. I was asking Mr. Finnegan to help, and he marked them all down weird. But I have like ABC and then.
Okay.
ABC.
Okay. So he did it slightly differently. So it's probably C. What's your answer for C?
For it's 20.
20? Let's check.
Angle C or hypotenuse C?
The distance, the length of the C. I have 23.1.
Oh, and I have 23.1 for B.
Okay. So that's fine. And 20 times tangent of 30, I got 10. Opposite over.
I have 11.54 for that.
What did I do wrong then? Opposite over adjacent. X over 20, 20 times tan 30.
Did you round up with the...
No, I bet what happened. Oh, I know what happened. 23.1 squared minus 20 squared, second square root. I have to change the question, because if you use trigonometry, the answer is 10. But if you use Pythagoras, the answer is 11.5, 11.6 actually. I have to change that because that triangle doesn't work. So, of course, I would accept either of those two answers. Again, though, the work is what matters. Now, did I say you had options to do this work? Yes. Did you have to do what I did? No. You could have used 60 over here and done this. You could have only found one side and then done Pythagoras, right? That is something you need to know now. And I spoke to that on the first day. There's more than one way to do almost all the math we are going to do this year, okay? And some of you may do things in a different order than I do. But if you get answers that make sense, it's all okay. Everybody with me? I know that some of you will have also had teachers that when you do the work differently than they do, they're like, no, don't do it that way. Do it the way I show you. I'm sure you've had a teacher that has said that as well. I don't say that. And let's say you ask your mom or your dad or your grandma or your grandpa or your auntie or your uncle or your older sister or your older brother or your third cousin twice removed, and they show you how to do some math that's different than what I showed you. Do not say to your person helping you, that's not the way my teacher showed me. Let them finish and then see if it works still. You picking up what I'm putting down? Okay. All right. Let us move on to more algebraic things. The reason trig was first is because trig is my favorite math. So that's why I made you do it first. I love doing trigonometry. I know that you're all thinking, oh my God, this guy's the lamest person in the world. But no, I'm not. There are lamer people than me. People that like doing other math other than trigonometry most. That was a joke. Everybody should be laughing now. No, you need to laugh now. This is when we laugh. If this was a comedy TV show, there'd be a sign behind me showing applause, 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 and you would be laughing like on TV. Because not everybody laughs at the same time on purpose, because not everybody thinks everything is funny. But when you watch old-timey TV shows and everybody laughs at the same time at just the right time, that's not real. You all know that already, though, right? Okay. Factor that expression. Holy crap, I can think of 5 ways to do this question. 5 ways. Okay? I don't care what method you use, but the answer is 2x plus 1 and x plus 7. And you could also have written it as x plus 7 and 2x plus 1. Now, if you forget how to do this, that's okay, because I'm going to remind you how to do it when we get to polynomials. All right? But that's the answer. If you can't remember how to factor, you're going to get a chance to relearn it, and you're going to need to be good at it to do pre-calc 11, and you're really going to need to be good at it if you choose to do pre-calculus 12 and calculus 12. Factoring is to higher level math what adding and subtracting was to grade 9 and 10 math. Does everybody follow me? It's like the knowing your alphabet and learning to read. You have to be good at factoring if you want to go further in math. Everybody cool? Okay. What are the factors of this expression? You divide everything by the greatest common factor, which is 9a squared c, and you write 9a squared c times 2a squared c squared minus 3c cubed plus a. And those are the 2 factors. Again, if you don't remember this, you don't need to worry, because I'm going to review it in polynomials. But it's something you will tell me that you completely forget if we get when it's time to tell me on Google Classroom, yes? I imagine, in my experience, this is, it's a little bit tough. Kids forget how to do it. And it's one of those things where you know how to do it or you don't know how to do it. And if you don't know how to do it, there's lots of little tricks to learn how to do it, but you've got to practice it a lot if you don't see it automatically. Or you understand what I mean? And if you're not willing to put the practice in, you're not going to be good at factoring. Cool? Okay. Well, not cool. I mean, it's factoring. It's not cool, right? It's not like you go to some party with all your friends, everybody sits down with some trinomials and factors them, right? That's not what happens. So I mean cool like you understand what I'm saying. Not, hey guys, let's go down to the library and factor, right? Okay. What are the factors of that one? That is x minus 8 times x minus 8. And of course, you could also write that as x minus 8 squared. And this is 2x. Hello? 2x plus 6 and 2x minus 6. Some of you might have stopped there. You can go further. You also could have done this as 4 times x minus 3 x plus 3. This is where you should be able to get to already, like from grade 10 work, but if you've forgotten, don't worry again, we'll review it. Everybody cool? But when I say review it, I mean we'll spend like 1 or 2 periods doing this old stuff, right? Okay. What's happening here? What's happening along here? That's time. What's happening here? That's distance. Yes? So what is happening on this graph? Something is going away from its starting point for how long? Not quite. About 3 seconds. So for the first 3 seconds, it's going away and it gets about 43.5 meters away from its starting point. Yes? Then what happens? It goes back to its starting point. Everybody with me? That's the easiest way. If you got that far, I'm happy. If you went further, even better, right? You could have said something was thrown in the air even. It doesn't matter. It's going away. The point is you understand that it's going away from its starting point and returning to its starting point. Everybody good? Okay. Oops, I got to make that a little bit smaller so it all fits on the screen. Where should you, there's 2 things I'm counting here, yes? What are the 2 things I'm counting? Time and speed, yes? One of those is a dependent variable. Which one? I'm expecting to see a lot of number 9s when I ask you. So, what would you, if you were going to draw this graph, what would go down here? Time. So everybody did know that time was an independent variable. And this would be speed, yes? Read the question. 15 seconds until you reach a speed of 10 meters. So, let's go. It goes, okay, so let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Accelerates for 15 seconds. So 5, 10, 15. So I got to get from 0 up to 10 in 15 seconds. So the beginning of your graph should be very steep up. Everybody with me? Then what? What now? What's the next 5 minutes? Does his speed change? So what happens to the line on the graph? Stays flat, like this, for 5 minutes, however long you did down here. And then what does it do? Goes back down. Does it go back down this steep or less steep? Less steep, because he took longer to slow down, yes? So it would have to go down like that. Everybody cool? Yeah? Okay. Now to get full marks on a question like this for me, you would not be allowed to do this. You would have to make it fit on the graph. Everybody good? Sweet. So as long as your graph looks something like this, steep, flat, less steep, you know what you're doing. Everybody cool? Remember how on Thursday I forgot my coffee? All right. This question. All you got to do is graph it. Those are x's, those are y's. There's your ordered pairs. That's an x, that's a y. -2, 1, 2, 3, 4, 5, 6, 7. -1, 1, 2, 3, 4, 5. 1, 1. 1, 2, 3, 4, 1, 2, 3, 4, 5. So there, you put the dots on the graph. That's it. Is it a linear function? Yes, because you go down 2 over 1, 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 down 2 over 1. All 3 dots are on the same line. All 4 dots, I mean. So yes, it is linear. Even though there's no line, it's still linear. Everybody cool? Again, this should be review for all of you. How do you know it's linear or nonlinear? It's linear because it has a constant rate of change, or you may call that slope. All of you should already know that, but I have become aware over the last couple of years that this is something that gets a little bit skipped in a lot of grade 10 classes. Okay? So if you don't remember this, there's a chance you were never shown it, even though you should have been. Cool? Everybody good? Okay. This f of x is negative 3x plus 7. I don't want the f of x. I want the f of negative 3. So I want the f of negative 3. So because that x is now a negative 3, all I do is put a negative 3 everywhere I see an x. Negative 3 times negative 3 is positive 9, plus 7 is 16. Everybody cool? Now, just for fun, I would like to ask, and this wasn't on the sheet, but it should be on the sheet. I should change this. What would you do if I told you f of x equaled negative 2? What would you do with that information? Serene, you can try. I mean, that's the whole point, right? Like, this is stuff you may not remember. Everybody may not remember it, so nothing can happen here. What would you do with that? It would be negative 3 in brackets. No, not quite, and that's why I'm talking about it. Because this is still an x, yes? All of you see f of x right there, yes? F of x is negative 2. So the negative 2 goes there. So it becomes negative 2 equals negative 3x plus 7, and then you have to find x. Okay? So of course you would subtract 7 from both sides. Negative 9 equals negative 3x, and x would equal positive 3. Everybody cool? Everybody remember that? Again, this is something that over the last few years I've noticed has been left out of a lot of grade 10 classes. It's not been left out of my grade 10 classes, but it's been left out of a lot of other grade 10 classes. Have you all seen this in the past and remember it slightly now? If not, don't worry. Again, we'll talk about it. Y-intercept of each line given its slope and its y-intercept. Oh, what is the x-intercept of each line? Sorry. So this, since you have a slope and a y-intercept, it's y equals negative 5x plus 20. And then I want the x-intercept. Every x-intercept in the universe is x comma 0, yes? You see right there an x, you see right there an x. This 0 is a y, you see right there a y. So all you do is you put 0 for y equals negative 5x plus 20, and then you solve. So x equaled 4. So the x-intercept, if x equals 4 and there's an x, the x-intercept is 4, 0. Does everybody remember that? Nice! So, of course, this one is 4 again. And this one is 9, negative 6 is negative 1.50. And you do the same thing. Everybody cool? This is something that always blows my mind. When you see any two numbers, somebody say a number, any number. This isn't a trick. Anybody say a number. What was your number?
53.
53. Somebody say another number. 53, 10. Every time you see two numbers like that, what are they?
Points in a graph.
They're points on a graph. And points on a graph are always x, y, aren't they?
Yeah.
So anytime you see an equation, 27x plus 32y equals q, what can you do with the x and the y? Put it in. 53 goes for x, 10 goes for y, and that will give you the last one. I don't know why kids have trouble with that. Anytime number, comma, number, it's x and y. And there's an equation that goes with it. The x goes for x, the 10 goes with y. The y goes with y, I mean. Cool? All right. Are we done? Oh, I wish we were done. Write the equation of this line. So, lots of ways to do it. The way I would do it is I would find the slope, which is y2 minus y1 over x2 minus x1, which would be 5 minus 3. Could I do 3 minus 5? Would I be allowed to do 3 minus 5? Who's the boss of me? Me. I could do 3 minus 5. But if I did 5 minus 3, my denominator must be 4 minus 2. If I did 3 minus 5, it would have to be 2 minus 4. And I would get 2 over 2, which is 1. So, now that I know my slope, I have lots of options. I could do y minus 5 equals x minus 4. I could do y minus 3 equals x minus 2. And I could do y equals x plus 1. All of those are acceptable. And if you don't remember how to do it, again, no worries. We're going to go over it later. Everybody still cool? How many people, just out of curiosity, did find that when you talked with each other or really thought about it, a lot of grade 10 came back? Are we generally feeling okay with our grade 10 skills? Generally? I know if you're not, just tell me on Google Classroom. You don't want to say it publicly. But everybody should be, especially with the whole extra day Friday to work with each other and Mr. Finnegan, everybody should be pretty, maybe not comfortable, but kind of like beside comfortable. You know what I mean? Like you're camping and you're on a mat, like a foamy, and it's okay. It's not your bed at home, but it's okay. That's where I want you to be right now. Are we all there? I hope so. Graph that system. Oh, wow, I really should have given you more space to do that. X minus 3, so you go down to minus 3, plus 3, you would draw that line. X plus y equals 9. You would go out to 9 and up to 9, and you would draw this, and there they would cross. That would be the answer. And down here you had to do algebra. Adults plus children equaled 400, and $13 for every adult plus $8 for every child equals 4,650, and then you solve that linear system. More than one way to do it. I personally, for this question, would have done this. C equals 400 minus A, and now that is C. So you would have done 13A plus 8 times 400 minus A equals 4,650. 13A plus 3,200 minus 8A equals 4,650. 5A equals 1,450, so A equals 230. So child equals 170. Is that right? I did it in my head, so I also haven't done a lot of math in the last month. So always remember, I do a lot of math in my head when I'm doing notes like this. If I make an error, do not correct me. you understand what I mean? It will not hurt my feelings. I'm working in my head. I'm writing it down. I'm talking to you. I'm trying to teach it to you. There's a lot going on up here. And I'm not as sharp as I used to be. And there are 30 of you desperately hoping I make a mistake, yes? And you want to pounce on me like a wolf on a sheep. That's okay. It will not hurt my feelings, okay? You checking it out, AJ? Did I do it right? I don't know if I did it right either, because I did 1,450 divided by 5 in my head. I did do it wrong. It's wrong. I can see it right now.
290.
It's 290, yes, and 110.
Yeah.
See? Now, I could do that thing that teachers do where they say, I made a mistake on purpose to see if you're paying attention. I never do that. And any teacher that tells you that is lying. They made a mistake and they don't want to appear like they don't know what they're doing. Okay? So, that's not true. I shouldn't generalize like that. You should never generalize. Get it? Because I just generalized by saying you should never generalize? Never mind. All right, that's it. So now, on Google Classroom, today, some point before the end of today, you will get a notification if you've joined the classroom that I have posted a new assignment. That assignment is this. I will ask you to tell me what you got out of 15, which means all these questions are only worth 1 mark because they're not really marks. If you didn't get it all by yourself 100% right, then don't say you got 15 out of 15. Do you understand what I mean? Give yourself a half mark for anything that you needed help with or didn't quite remember, and give yourself nothing if you were like, even if you understand it now. You with me? And in the comments section, private comment section, don't post it to everybody. Tell me the numbers that you're like, oh, I'm scared of questions like this. Does everybody understand? Yeah? Okay. Let's take a short break. Talk amongst yourselves for a moment before we get going with actual grade 11 work. Cool? Okay. I am going to attempt attendance. All right. The real number system. So it starts with natural numbers. Now, natural numbers, weirdly, are infinite. There's an infinite amount of natural numbers, so we can't really measure it, yes? But for regular people, for regular thinking, natural numbers is the smallest group of numbers, even though it goes to infinity. Everybody with me? Okay. If you were in kindergarten and I was your kindergarten teacher and it was 1985, say, because nowadays in kindergarten math, the goal at the end of 10 months of school is to be able to count to 10. That is what has happened to education in British Columbia, AJ. After 10 months in school, you should be able to count the months that you were there to get through all of kindergarten math. I'm not in charge, but I'm a little worried about the future, if you don't mind my saying. Not any of you, because you're all going to be great. You're going to do a good job taking care of the economy when I'm old and I need you to take care of me, right? I mean, none of you will be changing my diapers, but somebody will be. And you guys will be having the jobs that pay the government to change my diapers, right? Because you're going to be awesome. Anyways, if we were in kindergarten and I said, let's count, what would be the first thing you all said? 1. Would any of you say 0? No, maybe somebody who's got like engineer parents and they're super nerdy. Well, actually, Mrs. Bad Crumble, the first number is 0. Nobody would say that, would they? We would all start with 1. And then what would be the next number? 2. And what would be the next number? 3. And then if it was like last year and it was kindergarten, in June you'd be able to get to 10. And then you'd be like, I don't know. Right? Okay. So we all know that it is 1, 2, 3. And how far can we count? To infinity. Would we ever get there? No, of course not, because there is always infinity plus 1. Right? Okay. So we're just going to put 3 little dots. And then I'm going to draw the sign for infinity because I like drawing it. It's a sideways 8. The reason I like drawing it is because you can put a couple of little dots in it and turn it into eyes. You don't have to draw eyes when you make your infinity signs. But they're watching you. Okay, everybody good? All right, so now I'm going to draw a diagram over here. I'm going to put a basket shape like this. And those are our natural numbers. How many of them are there? An infinite amount. Everybody cool? Okay. Whole numbers. Now, I know you've heard the word whole numbers. Don't write this down. If I write 3 2/5, you all will say the whole number is 3, right? Right? Okay. That's not what this means. Not in our number system. In our number system, the whole numbers, and I'm going to change colors, are the natural numbers plus 0. So that kid that says, really, Mrs. Badcrumble, the first number is 0. This is when that kid is right. Okay? So it is 0. And then what's the next one? 1, 2, 3. Up to what? Infinity. How many whole numbers are there? An infinite amount. But there is one more whole number than there are natural numbers. With me? So just like those little Russian dolls that I can't remember the proper Russian name for. You know the dolls I mean. Yeah. Nesting dolls. This is our whole numbers. So if I have a number, and what's the letter that we always use for every number that we don't know? X. If I have X and I tell you X is a natural number, that automatically makes it a whole number. Is everybody with me? But if I tell you X is whole but not natural, then what is the only number X could be? 0. Does everyone understand? Sweet. Now we get to integers. Integers, I'm going to change color again. Anybody got a preference? Green. Integers are the whole numbers, and since they're the whole numbers, they already include the natural numbers, right? Mm-hmm. Plus negatives. So, what's the lowest number we can have? Negative infinity with no eyes. -3, -2, -1, 0, 1, 2, 3, up to positive infinity. Everybody cool? Now, even though there's an infinite amount of them, it's still double the size of the whole numbers, isn't it? So we make another basket, and I'm going to do this because I've screwed up my baskets here. Oh, still screwed up my baskets here. Oh no. Oh no. I'm not even touching the screen. Son of a bee. Close. 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 Solid technology. Okay. Up to there, except for negatives, up to there, that's about grade 3, yeah? And it's grade 3 in North America, not elsewhere, I don't know. But it's about grade 3 where math starts to go sideways for a bunch of you. And here's why. How old are you? I'm in grade 3. How old are you? I'm this many. How many is that? 1, 2, 3, 4, 5, 6, 7, 8. It's 8. Good job, kid. All right? We all are cool, yeah? Now, when I was a kid, if my mom said, if your mom had been in my class, she could have counted to infinity, yes? And here is where math gets crazy. How far is it on a number line? Because you all, Mrs. Bad Crumble in grade 5, had a number line around the top of the room, right? How far is it from 0 to 1? Infinity. Because you can keep splitting that number in half and never get there, can you? If your mom or dad or grandma or grandpa was really good at fractions, 2.5, 2 3/4, 2 7/8, 2 9/16, and would they ever get to 3? So would you ever have to clean your room? No. And this is where math goes in the pooper for a bunch of people. When you learn that not only do the numbers go to infinity, infinity lives right there. Everybody cool? And I know I'm not speaking to all of you, but if you think back to it, I like math if it wasn't for the numbers. There's infinite numbers right there, yes? So rational numbers are all the fractions. And if something's a fraction, it's automatically a decimal that repeats or ends. The fractions must look like this: x over y. X and y are integers, and y cannot equal 0. That's all the rest of the numbers. Now, just to make sure everybody's cool, is that a rational number? Yes, because it's a fraction. X and y are both integers, and y is not 0. Everybody good? Okay. What about this one? 2.5 over 3.5. It looks like it isn't, correct? Because there's decimals there. But isn't that just 25 over 35? If we multiplied them both by 10, and we know we can multiply fractions and keep the same value, and then isn't that just 5 over 7? Everybody cool with rational numbers? I don't want to spend a lot of time on them. Okay. And then we get to grade 10 when the next big jump occurs and you all of a sudden have to deal with irrational numbers, which are none of the above. What they are basically is the square root of anything. Actually, I'm going to put a little n there because it could be the cube root or the fourth root or whatever that doesn't work out perfectly. And some other famous irrational numbers like pi or e to the x, which is used in finance. Yep. All right. These are irrational. Now, until grade 10, if you had this, the square root of 7, you would punch that into your calculator and you would leave the answer as 2.4 blah, whatever it was, right? But then in grade 10, your teacher changed things around and told you that we want it in math class left like that. And again, don't worry, I'm going to remind you of how to do that. Is everybody good? Okay, that's the first thing we're doing this year. I want you to simply fill in page 6. That's your job. You have 15 minutes to do so, and you will have no math homework. Is that clear? Can you work on it with the kid beside you? Yes. Can you move around the room and work on it with whomever you wish? Yes. Do you have to work on it with somebody else? No. It is totally up to you. Are we cool? All right. Now, I talked a little longer than I usually like to talk, and I've only left you with like 13 minutes to work.